Mark my.
We spent chapter 4 mainly focusing on triangles, triangle congruence. And then chapter 5 we dealt a lot with triangles as well, like our centroid and angle bisector of a triangle. Now we're switching to quadrilaterals. Today we'll be able to define and classify the special types of quadrilaterals. So the first one is just the generic name. A quadrilateral is a polygon with 4 sides. That's any shape that has 4 sides. All right, and then there are some more classifications. If it has 0 pairs of parallel sides, it may be a kite. Now, a kite does have a couple special characteristics. It has 2 pairs of adjacent sides congruent. Remember, adjacent means next to or beside one another, but it will have no opposite sides congruent. So in a kite, you would have 1 pair of adjacent congruent sides and another pair of adjacent congruent sides. So I would add those markings to your picture. Okay. We also have quadrilaterals that may have 1 pair of parallel sides. Does anyone know what this shape's called? It has 1 pair of parallel sides. Starts with a T. Jeremiah? Jeremiah? Trapezoid. Trapezoid is a quadrilateral with exactly 1 pair of parallel sides. And then there also is a special type of trapezoid that can exist, and that's called an isosceles trapezoid. An isosceles trapezoid is a trapezoid whose non-parallel sides are congruent. So if you think about an isosceles triangle, we know an isosceles triangle has 1 pair of congruent sides and then the base angles. So in a trapezoid, you'll still have 1 pair of parallel sides that are opposite. The non-parallel sides will be congruent though. So kind of like how we call them the legs of the isosceles triangle. Those would be congruent as well. And of course, when you have parallel lines, we'll have like same side interior angles that'll show up inside of here, which we know are supplementary. And then the last pair set of problems has 2 pairs of parallel sides. The first one is a parallelogram. Parallelogram, again, has both pairs of opposite sides being parallel. So the left and the right are parallel, and the top and the bottom are parallel. The next one is a parallelogram, but it has 4 congruent sides. Does anyone know what that's called? It has 4 congruent sides. Not necessarily 4 right angles, okay, so don't say square yet, but 4 congruent sides.
Rhombus.
A rhombus, very good. So a rhombus is a parallelogram, but it's also going to have all 4 sides being congruent. Technically, we should also have the markings for parallel. Sometimes it just gets a little overwhelming, though. You want to make sure you have the congruent markings. The next one says a blank is a parallelogram with 4 right angles. What do you think that would be called? You can use the picture as a judgment as well. Maddie? A rectangle. So a rectangle is a parallelogram also, but it also has 4 right angles. And the last one is a parallelogram with 4 congruent sides and 4 right angles, and that would be our square. Now you may remember like earlier in the year when we did some of our like always, sometimes, never statements, where we would say if something is a square, it's also a parallelogram, or it's also a rectangle. Okay, a square would be the most precise name, but if it's a square, it actually is also a rectangle because it would follow all those properties. it would also be a rhombus, and it would also be a parallelogram. Now, if it were a rectangle, that does not mean it's a square. It could be, but if it's a rectangle, then it would also be a parallelogram. So this kind of just organizes all of the classifications. So if you want to, do you have this on your paper? Oh, it's on the back. Yes. Or is it on the bottom? I put it on. Okay. This is my old note sheet. So you'll just want to fill in the words. So kite over here. Quadrilateral is like the generic type for any four-sided shapes. If you have one pair of parallel, that could be your trapezoid or your isosceles trapezoid. And if you have two pairs of parallel, then it's a parallelogram, which can be classified further as a rectangle, a rhombus, or a square. This diagram is really useful for you to see all the different classifications. So if you were to name something as a square, you can pick up all of the titles that are above it too. So a square is also a rectangle, a square is also technically a rhombus, a square is a parallelogram, and it's a quadrilateral. Okay. Now, if I said it was a rectangle, again, you can only pick up the titles that are above it, not the ones that are the same height as it. So it would be a parallelogram and a quadrilateral. Okay, if they ask you to name it in as many ways as possible, that's what you would do. All right. Example 1, we have some algebra, and some of you like these problems. X. You do want to read the directions to know what markings you should add. It tells us that this is a parallelogram. So if this is a parallelogram, we want to mark that it has opposite sides being parallel. Both pairs. And they tell us that the measure of angle R is 2x minus 5. The measure of angle S is 3x plus 50. That's already put in. Okay. So we are going to use the fact that these are parallel lines to either say that angle R is congruent to S or is it supplementary to S. Joseph? Supplementary. So these two angles follow along this transversal. These would be same side interior angles, which we know, if lines parallel, those are supplementary. Therefore, they add to 180. Let's see. So we would say 2x minus 10 plus 3x plus 50 equals 180. Then just go ahead and combine your like terms on the left. Get 5x. Negative 10 plus 50 would be plus 40. And then you guys know how to solve from there. We would subtract and divide. Should get x equals 28. They didn't ask us to plug it back in, but sometimes they will ask you to find the measure of angle R. You could always plug it back in and make sure that these two angles do add up to 180 if you wanted to check your works. All right, example 2 tells us that this one is a rhombus. So again, the properties, the vocabulary from the front, you have to memorize what a rhombus is to know what, are you setting it equal or are you setting it equal to 180? So a rhombus is a parallelogram with 4 congruent sides. Okay, so we would mark all 4 sides with the same marking. You also could technically add in the parallel markings. We may or may not need them. Now, looking at our side lengths, we have an A here. We have a B here. We have an A there. Okay, all 4 of them have to be the same length. I would choose to set equal the ones that have the same variable, which are these two. And then once we figure out what that is, we'll plug it back in, find the side length, and then we'll be able to figure out what B is. So we would have our 5A plus 4 equals 3A plus E. Go ahead and solve that. should get a equals 2. Now they did ask us to find not just the values of variables, that's one part of it, but also the side lengths. So you want to take a and plug it back in. Both of those places we should get the same number, hopefully. So 5 times 2 is 10, plus 4 is 14. And 3 times 2 is 6, equals 14. So that's SL, or LS is 14, and NT is 14. They didn't tell us units, so I'll just put units. Obviously the other two should be 14, but you still have to figure out what B is, because it wants us to find the values of the variable. So since it's a rhombus, we know that all the sides would be 14. So this has to be 14, this has to be 14. So I'm going to create an equation right here, setting 4b minus 2 equal to 14. And solving that out, adding 2 to both sides and dividing by 4. Should get b as 4. And of course these will all be 14. Alright, the last one we'll take a look at is the longest one. Okay, these are kind of coordinate proofs where you're going to be proving what type of quadrilateral it is by graphing it in the coordinate plane and proving that you either have parallel sides using slope or proving that you have perpendicular sides using slope. We also will find out if the side lengths are the same by using the distance formula to verify whether or not it's a square, rectangle, a rhombus, or a kite. So the first step, you need to plot your points. And you probably want to label them with the letter. Some students don't do that and then they get really confused. So we would plot a point at -3, +3. Call that A. +2, 4, is B. 3, -1 is C. And then you want to take and connect those with segments. Okay, you are allowed to use your eye to judge it and say that it looks like something, but you can't just tell me that it's that because it looks like that. You'll have to prove it. All right? The sub-point is to graph your quadrilateral, and again, make sure you label the points. I'm going to hit the next slide because I have a better picture up there. A little bit nicer to see. All right, so first thing we're going to do is we're going to find the slope of each side to determine, is it a parallelogram? Is it a trapezoid? We only have one pair of parallel sides. So remember, slope, if they're parallel, they'll have the same slope. If they're perpendicular, what do we know about the slopes of perpendicular segments? Opposite reciprocals. Now, using your eye to judge this, what shape do you think this is? A what? A square. It looks like a square to me. But you have to prove that it's a square, proving that all 4 sides are congruent, and that the 2 adjacent sides are perpendicular, creating right angles. Okay, so we'll find the slope of AB. Now, you have 2 options for slope. You can either do y2 minus y1 over x2 minus x1. Since we have a graph, I would say, let's use rise over run. Just count. Much faster, right? So again, I typically start at the leftmost point, rise up 1, run over 1, 2, 3, 4, 5. So the slope of AB is 1/5. Find the slope of BC. I would start at B because that's the leftmost point. Okay? I'm going to have to rise down, that's negative 1, 2, 3, 4, 5. So that's a -5. And run over 1. Do you see how these are opposite reciprocals? Which means those 2 sides are perpendicular. So you can actually put a right angle box in. Okay, again, find the slope of CD. I would start at point D. That way I don't have to go backwards. So I would go up 1, run over 1, 2, 3, 4, 5. So that will be 1/5. And slope of DA, I would start at A because it's the leftmost point. I would climb down 1, 2, 3, 4, 5, -5 over 1. Which again, these are going to be opposite reciprocals, which means it's perpendicular. So we now know we have 4 right angles. Well, there's 2 shapes that have 4 right angles. Okay, so I have here, if the slopes are probably the same, equal, then the sides are parallel. If the slopes are opposite reciprocals, then the sides are perpendicular, just what I had written up there. So again, 4 right angles means that this is either a square or a rectangle. We need to determine the distances of the sides to see, are they all the same, which they appear to be, but we'll have to verify that with 4 distance formulas. So that's what the bell ringer question was, a distance formula question, because we're about to do it 4 times. All right, now those of you that struggle with the distance formula, you probably want to recopy the points down here. So like the distance from A to B would be -3, 3, 2, 4, so that you don't have to glance all the way back up at the top. And then you're going to do your distance formula. I won't sing the song today. We all should recall it. So x2 minus x1 squared. y2 minus y1 squared. You don't have to go reach for your calculator to take the square root of 26. You can actually just leave with the square root of 26 and then just make sure that all the other ones, if it's a square, come out to be 26. Okay? We'll do one more with you. So for BC, that would be 2, 4, 3, -1. Plug in. Remember, when you square a negative number, it becomes positive. So don't think this will be a -25. This will be a positive 25. Yes, I know this is tedious and time-consuming. But in order for you to actually verify that it is a square, you have to prove all 4 sides of the same number. Obviously, again, use your judgment to know that it looks like a square, so you should get all numbers being the same. If you get one of them to be different, you probably made an algebra mistake somewhere, so go back and check. Go ahead and find the slope for CD and DA and verify that it is either a square or a rectangle. But this is proving that we have 4 congruent sides. 4 congruent sides would indicate that it's a square, obviously, or a rhombus. Based on 4 congruent sides, a rhombus has 4 congruent sides also. But combining what we found in the previous part, 4 right angles and 4 congruent sides, this is definitely a square. And then if you take a look at the closure, it says, if ABCD is a square, what classifications from this lesson also apply? So if something is a square, which is the most precise name. Notice that's what it asked me for. The most precise name is a square. But what are the other ways that you can classify a square? A square is technically also a, Marquise? A rectangle. What else? A parallelogram. There's 2 more. Helen? A rhombus. And then the overarching title, Marquise? Quadrilateral. So on your homework, you'll see on the back of your note sheet, it just says quick reminder, when you're doing this problems, how to do it. Plot your points, find your slope, find the distance, and then based on all of those pieces of information, classify it. Notice on numbers 1 through 6, it says, judging by appearance, classify each quadrilateral in as many ways as possible. So you'll list all of those like we did in the closure. Number 7 through 12 says just determine the most precise name, so just one classification. And then number 13 on the back is the one that's the long problem that you have to show all your work for.